Betsy, if we go into, I'm a split, so if I go into one grade level, will I have access to the materials for the other grade level as well?
Yeah, the main thing for the breakout room is just for reviewing what you've done. Everything else we're going to just do in the big group. So it's just really reflecting on kind of what you guys did and sharing out how things went over the past couple of weeks.
Okay. Thank you.
Oh, and all the materials for everything will be in the slide deck, and all the resources will be there for everybody. So you'll get access to everything.
All right, thank you.
You should hear everything. Plus, we have a document actually that you'll fill out. So if anybody has any notes from other grades, you'll get to see those. Yeah. All right. So let's see how many, it's 3:34. We might want to get started.
All right. Well, we'd like to welcome you all back for session 2 of our Spring into Life Science series. And spring is pretty much here, probably same in Richmond as it is here in Oakland. So pretty warm day today, actually, and lots of things blooming. One of my favorite things right now are the poppies, the golden poppies that are all over Oakland at the moment. And my wife and I took a hike out at Mount Diablo and got to see a few wildflowers, but just the green right now, everything, despite the fact that we're only about half of the rain we should have got this year, things are still very green due to the late rains. So that was nice to see and experience. So yeah, just as Betsy mentioned, if you all could just put your grade number in front of your name in the Zoom, on your Zoom video, that would be fantastic. That way it'll make it real clean and easy for us to sort you into breakout rooms when we get to that point. So we'll introduce ourselves formally again, very briefly, since we've met most of you last time in a few slides, but I'm gonna turn it over to my colleague, Betsy. I'll be sharing my slides, my screen today, but Betsy and I will both be co-presenting for you again. So again, thanks for taking the afternoon with us for this workshop.
Yeah, so just to kind of retouch with, why we're here. We really appreciate you being here to work with us and work with each other to bring more hands-on activities to your students so that hopefully we can inspire them to, innovate, invent, think, solve problems, and be excited about that. Keep their curiosity going. Think about being an environmental steward. Look around at the world around you. Play with the world around you. So we really appreciate you being here to do that. And hopefully we will keep working together for years to come. Eric?
And as you know, CRS is here for you in so many ways. We're so happy that John invited us back for really a second series. We did the fall series with some of his teachers from your district as well. Enjoyed a physical science session, a couple sessions, and all of the resources, as Betsy mentioned, will be available to you. The link we can drop in chat and will be emailed to you. I should be recording if everyone is okay with that. So remind to myself to, we do want to record, right? Is that true?
Teresa would like us to record. That way anybody who couldn't come can see what happened.
Okay, let me make sure I can do that. Yep, I think I can. All right. So apologize, we're get back into our slide deck here.
Eric, I've already got the recording going, so if you want to,
okay,
I can just take care of it and I'll send it out to you guys.
Thanks so much, John. Appreciate it. Sorry, we're gonna get ourselves back in here.
Also, hello everyone.
Oh, right. We got to give John his.
Yes, thank you for being here, John. I appreciate you for sure. So CRS, as Betsy mentioned, one of the other things we're doing are some Thursday afternoon and Saturday morning environmental and climate literacy workshops. They range from transitional kindergarten all the way up through high school in age range and topic. We just did one yesterday on mapping and digital tools for ArcGIS. I'll be leading a worm workshop specifically, and using some role play as a teaching engagement and technique. So anyway, look for those online. We would love to have you participate in those, and they're free Thursday afternoons or Saturday mornings.
Okay, who we are. You guys know us already, been here several times before, but I'm Betsy Mitchell. I am a former research biologist, zoologist, and now I just love working with teachers and students and graduate students to bring everybody, scientists together and make classroom K-12 science more exciting for everyone. Eric?
And similar to Betsy, I have 25 plus years of informal science education, and I'm married to a formal educator, a transitional kindergarten teacher. So we both of us enjoy education, environmental education and climate science specifically are kind of my areas of great interest and passion. Energy education kind of ties with that, and sustainability. I've been doing with CRS a lot of professional development workshops with Betsy and the rest of the team. And I'm really enjoying that as well. So happy you're here and happy we have a chance to work with you again.
Okay, sorry, somebody wanted the link to the slideshow, so I was just going to copy the link.
Sure.
And I've got to change the settings here for a second.
While Betsy's getting that together, today's workshop is, again, it's the second half of what we started with you, which was, we're calling it our Spring into Life Science series. And we focused a lot on plants, observations, and kind of plants within ecosystems. And a little bit, we talked a lot about, not living or non-living things. But so today we're going to take that and move it forward and continue the idea of plants, but think about seeds, soils, and then a little bit more on ecosystems specifically and how that kind of ties everything together. And we'll be here with you again until about 5 o'clock this afternoon. So that's our game plan and our topic for today.
Yeah, and so what we're going to do today is we're going to explore some materials that you've gotten and think about ways to use them in your classroom. You'll have a little bit of time to plan and organize your materials, see what's there, and maybe some collaboration time. And really what we want to do is encourage students to spend time outside or spend time thinking about looking around outside and what's out there, and have some activities that they can do with their hands and have new ways to use their science notebooks. So that's really kind of what we're trying to bring to you today and every time we see you. So those are really, that's our goals and objectives for today. The agenda?
So yeah, so learners, be learners together, collaborate together, and then really encourage our students to spend time outdoors in this springtime. The agenda, so just kind of in those chunks, we want to give you a chance to review and reflect on what you all did in the last few weeks with respect to life science, thinking specifically about the lessons that we did with you and some of the topics and content that we covered, but also things that you did on your own, maybe something from mystery science or something else around ecosystems or some of the other life science topics that we covered, or that maybe we didn't. So feel free to kind of just reflect and review with your grade cohorts when we get there. Exciting. We understand that you're starting to get your student materials, and we'll look at those and unpack those specifically and spend some time with those, and you actually use those today. And then we've got 3 hands-on activities that we're going to just kind of get a small taste for. Plants and seeds, an exploration with soils, and then an owl pellet investigation. So Betsy and I will walk you through those and engage you in just some very small pieces of those, but these are obviously much bigger and can be extended over days, if not weeks, during the springtime here. And we do at the end want to give you a little bit of planning time with your grade cohort, kind of considering what you've been doing and then what we covered today. What creative ways might you bring some of these ideas and activities into your teaching for the next few months? Understanding that it's probably going to be in a distance learning kind of environment.
So just to kind of check back in with what we did last time, these are the thoughts that you had about things that you might do from the Jamboard that you filled out. So you had some ideas for prompts that you would use in notebooks, questions you might ask for discussions, and I'm having a really hard time reading that because it's too small. They're a little bigger. And then things that you could do synchronously and asynchronously. So sketching can be asynchronous, but it can also be synchronous, making models and sketching. And, you know, the kinds of prompts just that you might have used with your students. So if you want to peruse that for a second to kind of refresh your memory about thinking, about what you were thinking and what you might wanted to carry away with you, we'll move on to what we want you to do in your breakout room. Next slide. So this is you, Eric. Eric, you're muted, Eric.
Sorry about that. This was what we did with you, thinking about you as a learner and an observer yourselves first. So just a quick thumbs up, thumbs down if you were able to observe that plant that we had you identify at the beginning of last workshop. So just a quick, and no shame if you didn't do it. It's okay, didn't do your homework. There's no grades here today. But who was able to find, engage and think about that plant observation? Sort of a sideways thumb, a little bit. I'm seeing anybody else work with a plant at home? I'm seeing a few thumbs up, some sideways. So you thought about it a little bit. Maybe didn't do a formal exploration of it. That's fine. What we were asking for there was really, as a learner, what did you notice about that plant? Especially now in the spring, we anticipate a lot of changes with some of the plants out in our outdoor spaces. And then not only the plant, but the context of the plant, the ecosystem, what's around it? What was the weather like? Did the weather change? Did you notice any correlations with weather and something happening with your plant? Was anything else in the surrounding environment changing with that plant? And again, did those changes seem to correlate with anything happening and interesting observations about your plant? So that's as a learner yourself. But then we want you also to think about with your students. And so on this one, if you did do this yourselves, did you try it out with your students? What did they notice about the plant potentially that you know, basically same process that you went through? What did they observe? Why did they pick that plant? Why was it interesting? Did it change over time? A lot of science is about observation and watching change over time. And then sharing those observations with one another. Maybe some students picked something similar, same kind of a plant. Maybe they picked, a couple students picked trees, for example. So just thinking about that specific activity, but then in the broader context of what we covered last time, we also talked about, in connecting to this activity, plants within an ecosystem or an environment that has both living and non-living things, abiotic and biotic factors. So observing those things in a broader context, did you have students kind of start to unpack the idea of a living and non-living thing and how those things influence an ecosystem? What are their kind of relative roles, let's say, within supporting something that's growing? And did you do any other activities that you might want to tie in? We've been trying to really tie in specifically to mystery science because we know a lot of you are using that and are excited about that curriculum, and it is very accessible, and there's lots of great resources there to utilize in the classroom. So anything that you did with mystery science, or potentially anything else that you've already, you know, that maybe you've done gardening with your students in the past. Maybe you've kind of leveraged some of those materials and activities that you've used in the past. So we'd like you to think about those pieces as we get you into breakout rooms and reflect on that as well.
Okay, hey guys, can you be quiet, please? Okay, sorry. Sitting in the dining room. So we're going to put you in grade level breakout rooms so you can review and reflect on what you've been doing, just as Eric described. And so there's a few things to consider. And what we've done is created a Google slide deck. And if you would just find a page that's labeled with your grade level, and if there isn't one left for your group with your grade level, you can go ahead and change it. And then just record. Oh, they're not labeled there. It's just fill in. That's right. And so just record your ideas here, and the prompts are there. What activities did you do? What tools of science did you use? Any tips to pass on? What was asynchronous and so on. So if you just record that, then we can share that with people later. So the link for that is in the chat now. And we're just gonna, let's see, what time is it? We're just gonna give you about maybe 7 minutes to reflect, 6 or 7 minutes to just chat about what you've been doing and then share it in the document.
And find, as Betsy mentioned, find an empty page and work together with your grade level cohort and share ideas and just capture them here.
An empty page for your breakout group. Okay, so let's see. We have 19 participants. So we want about 3. Okay. All right, I'm gonna make the breakout rooms.
Work. So just quickly, if folks want to popcorn in or just drop something in the chat about what's worked well, both synchronously and asynchronously. Also, if you've had a chance to engage the students in any of the sketching, in addition to some of the content and ideas that we presented. So yeah, just a real quick reflection on your conversation and or your intentions, you know.
Jamboard. So Lisa, you used Jamboard?
Great.
And how did that work? It was good?
Yeah, I mean, for the living and non-living, I was telling my group that I started off by showing them a bird's egg I had found
Oh, perfect.
to get them a discussion about, like, is this living or non-living? And it really brought up a lot of discussion because a lot of kids really didn't understand, like, what makes a living thing? Why is something that's, you know, when is something alive? So it was a good discussion.
And the jam, so you did this synchronously with them and they used a Jamboard?
Yeah, I kind of started putting their ideas just as viewer, and then I let them go in and add and make their own jams about it.
Nice. Great. Did anybody have any drawing asynchronously or any kind of work asynchronously related to the things that we introduced last time? Pretty hard, huh?
I actually put together a lesson though for distance learning. You know, I downloaded like a video how to draw flowers scientifically, and then charts about the different parts of a flower, how to label them. And then I downloaded some images of flowers so that they get, everything is online now, so they get sketched according to the pictures that I drew, and following like along with the tips that the video gives them how to draw flowers scientifically and to scale and things like that. So I haven't run it yet just yet, but of course I'm trying to plan it for online. Yeah, so.
Right, so that's intentionally planning for it to go that way. It'd be interesting to hear.
And then eventually, you know, they get together a sketchbook, you know, so like a scientific sketchbook or something like that. But I'm just trying to get the initial lessons going. Oh, how do you sketch scientifically? So.
So this is an interesting comment that the kids had a difficult time focusing on just one growing thing. They want to draw everything. So that, like, when you're in person with the kids and you can help direct their attention, it works better. Is that kind of, yeah.
Betsy?
Yeah.
Sorry, I couldn't raise my hand. I'm on my phone. I apologize. I got kicked off my laptop. But we, unfortunately, the timing of your stuff came like while I was trying to get through the Chabot Space and Science stuff. So, but of course I use everything we've learned at CRS in terms of like, so we've done like some sketching of the solar system, which we label. And so yes, I'm trying to do some diagrams and labeling and, but no, I haven't been able to get through this stuff because I'm trying to get through the Chabot Space and Science material. So.
That's great though. That's fine. Wonderful. That's just equally wonderful, right?
Yeah,
Yeah, it's not as hands-on, but it is fascinating. It's incredible how many kids perk up when we're talking about planets and, you know, all that other asteroids and everything. So,
Well, yeah, one technique I used to use when I worked there for years, I taught a class on gardening and would basically treat Earth as the living garden planet. So it's a way to
ooh,
actually bring it in and say, especially look at the first four planets, right? Our rocky,
oh yeah.
you know, and why aren't, you know, Mercury, Venus, and Mars habitable, especially with Perseverance landing recently. You've got that sort of Mars and Earth comparison, and you know, Mars is the most Earth-like planet that we've got besides Earth, right? But
That would be a great way to get into the plants, and hopefully very soon, because
and you know what they
I
need.
want to take advantage of the spring stuff happening in the spring.
Exactly. What does Earth provide, and why is it unique? You know, what
Yes.
the living world type of thing. So, but that's great. You're doing that stuff.
Yeah. Okay, well, I think we should probably move on.
So
Thank you for all of your feedback and your comments and your sharing. It's great.
So here's a picture of the supply kit that we hope that you got. So just again, a quick show of hands. It's a two-part question. Thumbs up if you've got your supplies at your site. You've got your supplies. Awesome. Thumbs up if you've had a chance to organize them into the student kits yet. Oh, I'm seeing some thumbs up. And if not, great. We are going to leave a little bit of time. And we did see in the notes that some of you were planning on doing some of these things after spring break. So that gives you a week or two to organize your supplies. But you'll get a bag, kind of very similar to what you're seeing in the upper left corner here. And if you unpack that bag, this is what's inside. These are all the goodies that you've got available to you to explore with. And they're listed here on the left. So kind of the details of what you've got in the image. And on the right are some suggested supplies and materials that we'd love it if, you know, you would encourage your students to gather. And I imagine some of these things, you know, they've already got in place, like pens and pencils, hopefully scissors and tape, water. But toothpicks for one of the activities we do, and paper towels was not something that we included in these kits, but they would be useful for a couple of the explorations we're going to do together. So that's kind of the global kit. And then from this, we're going to introduce pieces of three discrete activities that we'd like you to consider engaging your students in over the next couple of months during the last 2 months of school. So we're going to start with activity number 1, which is about plants and seeds. And I'll turn it over to Betsy.
Right. So basically, we kind of have a, excuse me, an overall broad question: how do plants grow? And with the materials that we've given you, you can begin to address this sort of broad question. And you can also take it in many different directions. So sort of from that, if you look at, next slide. What you have some plastic bags and some bean seeds and some radish seeds. And if you take a paper towel and you dampen it and you put the seeds on that, stick it in the Ziploc bag and just leave it, those seeds will germinate. Has anybody done that? Yeah, so that's a pretty easy way to germinate seeds. You have these little flower things, and you can just add water, put it on a plate, and let those seeds germinate there. And then you have some cups and these soil pellets, and you can create a cup of soil, and you can germinate seeds in there as well. So those are the materials that you have to start actually growing some stuff. You also have the tools that we used last time of drawing and labeling and diagramming. So all of those things that we did last time about observing and drawing and labeling, you can apply here. And so what I wanted to do, next slide, was just have you take a peek at the performance expectations for grades 3, 4, and 5. And think about, is there any way that you could connect these to germinating seeds, or that you would want to? Or are there other things that you think would be good to do with those materials? So for 3rd grade, one of the performance expectations is to develop models that describe that organisms have unique and diverse life cycles, but that all organisms have in common birth, growth, reproduction, and death. So could you tie that? Is there a tie in there for you? Is that interesting to you? Would it be interesting to your students? construct an argument that plants and animals have internal and external structures that function to support survival, growth, behavior, and reproduction. So trying to take the kids a little bit farther besides just, what's happening, but give them some discussion questions that they could think about what they're observing as they're observing and recording in their notebooks. And then support an argument that plants for 5th grade get the materials they need for growth chiefly from air and water. So does anybody have any thoughts? Just take a minute and think about it. And if anybody has any ideas that they would like to share out, that would be awesome. Just think for a minute about, what kind of thing might you like to do with germinating seeds, or have you done that you would want to do again with these materials?
In terms of putting the seeds in the plastic bags, I've done that before. And one thing, and I saw this somewhere, and I did it one year, is you staple sort of almost through the middle so that when you drop the seed in, it just falls to the middle of the bag. I mean, you don't have to do this, but that way the roots kind of go down and the plant goes up, but it just sort of separates it nicely. So that's one way to do it. And the only issue I've had with that is, man, those things start rotting and they would stink up the classroom. So I think that is an issue sometimes with the seeds in the plastic bags.
Right. After a week, it really starts, you'll get mold. The seeds will keep going. It's a trade-off between, do I need to water it, or, do I want it to rot? So yeah. One thing you can do is, once you've got a germinated seed, you could put it in a cup of soil and let it continue to grow in the soil. But then again, you do have to water it. You can also put them into bottles, and make a little terrarium. That's a great tip about the staple. I like it. I also like the fact that the hole might let a little bit of air in. I always like to puff the bag up so that there's a little bit of space in the bag as well. Other thoughts about what you might do?
I actually had a bunch of all different types of seeds that I collected when I used to do this garden at my previous location, and I have all these seeds. Hopefully they're still viable, but we might just have like a little discussion. Oh, let's talk about. I guess sometimes how they plant the seeds. Sometimes they give it more sun, less water, or something, and see which one does better. But we might just have a discussion. Okay, what do you think these plants need? How much water? How much sun? Let's just go for that. Mm-hmm. And we have different types of plants, different types of seeds. We might talk about the timing of planting them as well, I guess, the seasonal thing. But we might just do something easy like that, I guess, just to start them thinking about what different plants need, I guess. Just a thought. I mean, that's what I was thinking of doing, something easy.
You have a lot of materials. That's really great. You have a lot of materials in here that you can make comparisons with. So you have different types of seeds, so you can look at different structures for different species. Are they the same? How are they the same? How are they different? You could compare growth need, if it gets more or less light, more or less water, more with soil, without soil, all that kind of thing. So there's lots of ways to set up experiments and just start kids thinking about that process of making a comparison, manipulating something to see what happens, which is the coolest thing ever. That's what an experiment is. That's all an experiment is. So all of those things. I think if you wanted to think about life cycles, you're starting with a seed and you're creating a seedling, and then you're creating a plant, and then you they can kind of fill in the rest of it, and you could compare that to an animal, so that there would be kind of ways of taking their observations and giving them something else to think about to extend the way they think about what they've observed, or use their observations in a new way.
And
okay, I'm going to move on.
I saw a hand up from Ms. Santos, but it went down.
Oh, sorry.
Ms. Santos, did you have a question?
No, actually.
Okay, all right, thanks.
Okay, so I just wanted to kind of show you a little phenomena that is kind of cool, and it's really mainly a 5th grade thing. Next slide. Keep going. So here, how does this teeny tiny seed become this giant sequoia? So there's something that happens in there. How does that happen? How does this work? What happens in between the seed and the adult plant? So that's a question you can pose, and you can explore that question by germinating seeds and just see what happens. Next slide. But so you could brainstorm. So where does the material come from for a seed or a seedling to make all that wood and the stems and the leaves that it has as an adult plant? Another way to think about it is, what do plants eat, right? Because we eat and we get materials that we build our bodies with. Well, plants have to do something like that. So and so generate some ideas. So what do you guys think? Where do plants get all that material? What do you think the most common idea is? What would be an idea for
Probably the dirt from the soil.
right, that they're getting this from the soil? So, okay, so here's a hypothesis. They get it from the soil. How could we test that? Very simple experiment. Grow a plant with soil and grow a plant without soil. So that directly addresses this idea that plants actually get the matter that they build their bodies with from air and water, and that it's not really from the soil. So next slide. So that's just one experiment that you could set up with that phenomenon. And I just, back one. Here. So Mystery Science has a lesson called What Do Plants Eat? If you wanted more resources for that. And then there's an experiment by somebody called Van Helmont, who actually planted a tree for many years in a fixed weight of soil. And he weighed the tree before and after, and he weighed the soil before and after. And it's a clear demonstration that the soil does not contribute to all that growth of the plant. So those are just some nice resources for you. And next slide. And then there's a couple of other resources here for life cycles and just observing germination. Okay, next slide.
All right, so before we jump into soil exploration, I'm going to stop sharing for a minute because I got a new toy that I had to kick us off with. So let me just stop sharing for a minute. And I'm going to pin my screen, I think. Can you all see my screen? Is it big for you?
If you make the speaker view, you'll see it big.
Thank you. So this is to Betsy's point. So this is a digital microscope, and that right there is a redwood seed. So that's actually from a California coastal redwood seed. So you can see in relationship to a penny how big that seed is. And this seed has the capability to grow to be over 200 feet tall. So the tallest living things on Earth, whoops, I just popped it off. There's a few more, grow from seeds that start here. So I think starting with these kind of discrepant events or sort of big ideas, if you will, are really fun ways to engage the students in the lesson themselves. Anyway, just thought that the fact that little guy right there could become the tallest living thing on the earth, to me has always been incredible. And when I used to do hikes at Chabot, that was one of the first things we'd do is we'd go find a redwood cone, one of these guys, and out from that cone would spill maybe 40 some odd of these seeds, each of which has the capacity to become a very, very tall tree. And what is that tree going to need though along that 2,000-year journey to get to be that tallest thing in the world potentially? All right, so I'm going to start sharing again, I think. So we're going to jump from seeds into plants, really, and soils. So let's bring this back. Sorry, trying to navigate. There we go. And pardon me, get back into where we were.
Slide 21.
Yeah, thanks, Betsy. All right, so soil exploration is really a nice hands-on way to get your students engaged in activities. And so just real quick, and you can, again, popcorn in vocally, unmute yourself or drop in chat. Just some of these intro questions. What is soil? Why is it important? Where do soils come from? How are they formed? What are they made of? And how are they similar and different from one another? What can you find inside the soil? Are there living and non-living things in the soil? How do you know? Although not listed here, Another question could be, what kind of soil do specific plants need? Do all plants need the same kind of soil? Or back to the original idea that plants are actually not getting as much from the soil as they are from the water and the air itself. So most of the plant material that's gathered in the base, the carbon, is coming from the carbon dioxide that it actually fixes through the air. So plants are kind of growing from the air down, if you will, but they do need some things from the soil, we know as well. So kind of just thinking of some questions to get the students thinking about plants and those seeds and their relationship to the soil. Any thoughts or any ideas to contribute on any of those questions? And these are great journal prompts too. If we've got the journals that that you're going to get inside of those kits, right? It's a little, and you probably got them doing journals, but it's the little green books. They can customize and make their own journals. So really quickly here are some soils in pictures of soils. And what do you observe as scientists, as explorers? What kind of catches your eye? Maybe there's one that looks interesting. Maybe you're starting to compare and contrast them. How are they similar? How are they different? What do you notice? What do you wonder?
I'm noticing that some of the soils are extremely dry or even cracked, and others are very wet. They have a lot of liquid in them.
Nice. So even from the pictures, we can tease out sort of the moisture levels. That's great. Anything else jump out at you? Is there one that caught your eye for some reason?
Well, I just noticed that they seem to be different colors. Like I see gray, I see kind of a reddish brown, and then different types of brown. So I think that's kind of interesting.
Great. One of my favorite things to do at Chabot was I would have a couple soils, one of which came from the Sierra Nevada mountains, and it looked very much like that bottom one, third from the left, that reddish color. And the kids would always ask, did that come from Mars? Is that a Martian soil? Oh, why do you think that? But I said, we've never been able to bring back a sample yet, but this latest Mars rover is actually caching soil samples to eventually bring on what they call a sample return mission, probably in the 2030s. We'll retrieve these cached soil samples that Perseverance is going to be collecting. Anything else? All right, well, those are good starter.
What other differences do you notice? That color was one.
Mm-hmm.
Any other differences? Oh, and dryness.
Mm-hmm.
Anything else?
I would wonder which soil is more fertile and maybe what minerals are contained in the soil.
Great. All right.
Also,
Go ahead.
well, that some soil seems to have more plant matter in it. Like I see dried grass in some of it, whereas others seem to have more like rocks. And so they have different consistencies, textures.
Great. So a couple things. Yeah, just keying in on what you said, the textures, how they feel, not only the moisture, but maybe the coarseness of them. And then the abiotic and biotic factors you're pointing out. So the living and non-living things that kind of we talked about in our last session. Great. Here's a real quick macro view of soils in our country, soil map of the US. So they are very different depending on where you are. They have different ages, they're of different types.
Different minerals.
Yeah, minerals, content. So to set up a real simple soil exploration, this is the part of your kit you might consider using. And so I just took a photograph of the things that you could use for this exploration specifically. Just a show of hands, I know we were going to put a call out. Did anybody retrieve your own soil sample for this afternoon? Just a thumbs up or a thumbs down if you did grab soil from your garden. I'm seeing thumbs down. I see some people showing off what they've got. Excellent.
Yeah, good.
Excellent. So if you've got one, great. If you don't, that's no problem. Either way, we will work with that. And so in your kits, you've got these things, and the 3 cylinders there, the 3 circles, those are soil pellets, basically. And Betsy's got one she's showing off there in her hand. You know what, I need to change. So you can actually hydrate this soil. So basically what Betsy's done, you can see what she did. If you take that puck and you drop it into one of your plastic cups and you fill it to twice the height of the puck, that seemed to be the right amount of water, that you'll get a really nice moist soil that's not a swamp. So in terms of the amount of water, if you just pour the water in over your puck, feel free to do that right now if you've got it in front of you and you want to explore with us as we go. So again, dropping 1 puck at the bottom of the cup and then pouring in water so that it's twice the height of the puck itself, with the puck being flat, the pellet being flat. All right. And then you've got some popsicle sticks you can use for probes. You do have some droppers, though I wouldn't advise putting the water in with the droppers. It'll take too long. Just pour it in over the top. Your journal for taking some notes and setting up your exploration sheet. And then take a moment to set up in your journal, if you want, maybe something that looks like this. Basically, it's a data sheet. So you can open up your journal to 2 pages. On the left side, you can set up and label it soil 1. And on the right, you can label it soil 2. I'll give you a minute to get that set up if you're working on that.
Eric, your microscope camera is still.
Yeah, I'm trying to figure out how to turn that puppy off. So
It's currently a penny
yeah, thank you.
and a redwood seed.
Let me move to this camera. I'm going to unplug here for a minute while we're getting set up. All right. So as you're getting that set up, and basically what we're going to do is we're going to record some things on this paper together as you're exploring your soils. And I'm going to stop sharing for a minute. And okay, switching to a different kind. This is an Elmo now. Just, I'm not sure if a lot of you are using Elmos at school, but so this is a little bit more of a macro or wider, field of view. So I just got a plate, and you can do this a couple of ways, right, with your students. You set up your journal and you just label it, soil 1, soil 2. You could certainly, add that this was the soil pellet. Maybe they want to label it as the pellet. Sorry, my chicken scratch. I'm not sure if you can see that very well. And then this one might be your collected soil, and they could put the date they collected it. So in my case, I've got some compost, which was collected today at 3:31 from my compost bin, my worm bin in the backyard. So that could be maybe a data sheet, on a plate. Yeah, I just put this as another way of working with your soils. Here's that soil puck material. And sorry, my end. Let me put this in gallery view. If it's not, speaker view, great. So that's the soil from my puck right there. So the first thing in either, just having them start using their probes to explore through that. What kind of things do they observe? What color is that soil? What's the texture of it? We mentioned you mentioned the idea of moisture level, so you could feel so beyond texture, how does it feel? Does it feel wet or dry? What kind of things can they find inside? Certainly, it's not something we put on the list, but if you've got a hand lens and you want to kind of get in there and get a better look, hand lenses are great. And then just recording those words. You know, another way of doing this together synchronously is have them drop the soil right on the page, right? Right there, you could tape that down as a sample, and then you could start writing your descriptive words. Well, to me, that's kind of brown. And it's definitely got, it's moist. I wouldn't say it's super wet, but I call it moist. And when I look inside, I don't know if anybody can see anything inside from where you are. I'll bring it a little closer up. Anybody want to, any observations? Or maybe you're making observations of your own soil because you've got the same pellet if you've expanded it. It takes a few minutes for those pellets to expand. So you may not be at a point you can explore it yet. But I don't know if you can see it. There's definitely some little twigs in there. So just kind of writing those words down. If you want, they can color code, by the colors itself could be written in a red pen or red pencil. How it feels might be another color. The third color might be what you find inside, the objects or materials you find inside. And you could start that idea of, is it biotic or abiotic too? Just kind of thinking about that. And then the same process for soil too. And with the younger ones, I'd always start with really distinct soils. Like I was mentioning, that soil that came from my dad's garden up in the Sierra Nevadas was, really red in color. So it was a super distinct, there was a huge difference right off the bat that the younger students could observe. And then this was the finale soil that I give them. And this was a class I taught for TK to 5th grade, and would just scale it up based on the students and scale up the conversation and things we'd cover. But this was sort of the finale soil, and in it was the star of the show, the red wiggler. And our little Essenia fetida is a compost worm. So right away they would, either get super excited or they would jump off the table and say, yeah, and try and get away from it. Either way, it was a lot of fun and highly engaging. So, finding those hooks and fun things for them to do. So I want to, that's just a real simple soil observation, compare and contrast. And I think with the materials that we've sent home that John has kind of arranged to get to you and that you have and that you're getting to your students, it should be, relatively accessible exploration. The one thing, and this was open conversation, I want to hear from you, would they have access to a second soil? Do you feel like your students just going outside in their communities, in their day-to-day kind of, outdoors, just grabbing any soil that they find, using one of those cups, and then, if you could set them up asynchronously to do this as an expectation, it would be really nice if they had their own soil to explore with. And I'm gonna start resharing again, but again, has anybody done a kind of a soil exploration before? Anything you'd want to share from that?
Anybody have any thoughts about good discussion questions from after doing a comparison like this? How might you generate some discussion about what the observations or the data that you've collected? We had some focus questions up at the beginning that might be, what is the soil made of? So after observing, maybe you can take some observations and you could answer that question. What is soil made of? Or how are they similar and different from one another? So there could be some writing that went along after doing the observation, journal entry around that focus question. I think it's also really cool to take local soils, because they're going to be really different. Different people are going to get some really different things. Another thing you can do with soil is put it in a jar of water and shake it up and then let it settle. And the larger things settle out first, and then the organic material settles on the top. And so you can often get an idea of how much organic matter and how much sand and different kind of components are in your soil sample just by shaking it up in water and letting it settle. It's kind of a neat way to see the components.
So in your journal, again, just kind of, reviewing kind of the idea would be just use that as a place for them to make some observations and do some recording of that data. And real simple example of that, again, the one on the computer screen, I've kind of color coded the 3 prompting questions or, exploration questions. What color is your soil? Maybe they record that in a color of their choice. How's it feel is another one. And what's inside, or you could have them do more formal columns for each of those things. And then how does it compare with soil 2? Compare and contrast. And then just to kind of wrap this up, this was an interesting graph that Betsy found. And I was actually kind of amazed at this. What's in soil? And, it turns out that a very small part of soil is actually organic matter, 5%. And of that 5%, only 10% of the 5%, which is 0.5%, less than a percentage, is living organisms. So soil is mainly abiotic. It's mainly air, water, and mineral particles, 95%. And then, again, the actual living part of the soil, now it may be organic, it may have had a living origin, but it's not living anymore. So yeah, the main parts of soil are non-living. But that to me was interesting, just kind of reflecting on that, even as Betsy and I were putting this together. So we're going to move from soils, seeds and soils, now onto sort of the bigger ecosystem at large through our final exploration. And we're going to think of it in the context of a food web. And so it turns out, just to kind of make the transition from soils, compost itself is a very complex ecosystem. You've got those red wigglers sort of towards the top of the food chain. Although if a bird got in there, the worm wouldn't be on top anymore, right? But then you've got the fungi and bacteria and the abiotic things kind of at the bottom, right? And then everything kind of moves through. So you've got kind of an ecosystem just within soil itself. And there's a neat link there to a food chain lesson, Mystery Science. You'll have the slide deck, so you'll have access to that. A lot of good Mystery Science connections for this content area. And then beyond that, we can think kind of beyond the soil into a larger ecosystem that we're gonna think about owl pellets and how they tie. And so Betsy's gonna kind of run us through a little bit about owl pellet investigations and some kind of small pieces of that. And so I'm going to turn it back over to Betsy. Oh, you're on mute, Betsy.
Yes, thank you. You all have these little owl pellets, and so that's kind of the subject of the next investigation. My first question is, how many of you have done owl pellet investigations already? So not everybody, but a lot of you have. Okay. Okay. Well, so next slide. So just as a way of kind of introducing the phenomenon of owl pellets, you might start out by just talking about owls. What do you know about owls? And just have a conversation about that. So, you could just ask students, what do you think you know? And just generate a list. You could show a video, and I have some videos for you in the resource list, and just observe an owl flying and hunting. And then, what do you notice? First, watch the video, what do you notice? And then watch it again and maybe take some notes in your notebook. Next slide. And then we can start by asking the question or talking about how will scientists study owls by observing their behavior? And so here are 2 actual owl biologists. And one question they might ask is, what do they eat? Next slide. And so there's a way to find that out, because owls eat their food whole. They don't have strong bills and talons enough to really shred it like a lot of other raptors do. So they eat it whole. It goes into their stomach, and their stomach acids can digest the soft tissue, but they're not strong enough to digest the fur or the bones. So while it's in there, it's digested away the soft tissue, but the bones and fur are then compacted by the muscular stomach into a pellet that then the owl regurgitates. So that's basically kind of how they eat. And here's a little link for a video that shows an owl regurgitating a pellet. Next slide. So we can ask that question, what does a barn owl eat? By exploring what is in the owl pellet, because all of the bones from the animals that it's eating are going to be left in this pellet, and we can identify those food items that way. So the thing to do is, if you want to do this right now, is just get out your owl pellet, and Eric's going to show you on his camera kind of how to pull them apart. So there's a couple things I want to say about it. First is it's only fur and bone. It's not a poop. It's a throw up, but it's all dry. And all of the commercially available owl pellets have been completely sterilized. They get baked in an oven for a really, really long time. So even though it seems icky, it's all very sterilized, very clean. It's not slimy. There's nothing in it that's going to hurt you. And the other thing is that the bones inside are very, very delicate. And so if you look at, this is a little skull that was in it, and already you can see that half of the cranium has broken off because it's very thin. So what the kids need to be really, really careful when they pull them apart to not crush it or break it hard. You want to very gently pull it apart. So if you want to, Eric, you want to take over and
Sure.
show?
Yeah, so here's that skull that Betsy was talking about. So Betsy and I went through this, and we pulled apart half of one of them. This is the other half that we didn't, and you've got two. Your kits, each of the students will get two, and you should have two of these aluminum balls with the owl pellet inside. So here's half of the one that we started to take apart yesterday. And the trick that is just to be really, really gentle, right? So you want to just kind of gently pull it apart with your hands and trying to be mindful of not cracking any of those bones apart. So you can kind of start to tease it apart like this, and just, I heard a crack, but just opening it up. And then both your tweezers are a good tool, kind of like an excavator. An archaeologist would excavate carefully with a little broom and sweep away the sand. You're just gonna excavate away some of the fur around the things you're finding until you get to something interesting. So here's something. Another great tool for this are the toothpicks. So because they're just, the popsicle sticks aren't great because they're too big, right? But the toothpick makes a nice little probe / excavation tool. You might use two at the same time and just pick away at your pellet until you kind of start to get to some of those bones and other things you find. And then it becomes kind of a sorting opportunity, right? So get your fur kind of pushed off to one side, start to kind of put your bones into a pile, right? And then from there, you can start to look at the bones by type. You know, this is a long, skinny one. This one seems to have something that looks like teeth to me, so maybe I'll stick that in its own little pile. That skull that we found earlier. Here's another one that looks like it's got some teeth. You just start to kind of organize your pellet by what you find inside and what the objects look like. So that's the initial exploration.
Okay.
Unpin.
And next slide, when you get to it.
Sure.
So you're going to end up with a tray, a plate full of stuff. And once you've got that, the next thing to do is say, okay, well, what have we learned from this? And one thing you need to do is start sorting the bones and figure out what's in there. And when I get the slides, you'll see an example of that, or how to do that. Next slide. Yeah. So this is what the skulls look like. Generally, you're going to find vole skulls. It's a small mouse, meadow mouse. And they're really, really common in fields, and barn owls eat tons of them. They also eat shrews. There's a bunch of different stuff that they eat, but there are these bone charts that have images of all the different skulls. And the best way to identify the stuff is by looking at the skull. And but you can also, if you don't have a skull, you can also know how many prey items are in there if you count, like, for example, the number of hips. So like there's 2 sides for each hip, right? And if you find 4 hip bones, you know you have at least 2 prey items in there. And you can also kind of compare them on the chart to try to figure out what you have. So the next step would be to try to identify, have the kids identify what kind of animals the bones belong to, and think about how many prey items are in the pellet, and then record those data into the notebook. Next slide. So now you want to maybe take some time to have the students make a claim and think about their evidence. So you can ask them to explain what they think barn owls eat. You can also get class data. If everybody reports what they found on a chart, you can ask the question, what is the most common food? Or you can just ask, based on the pellet that they've observed, I claim owls eat blank and my evidence is blank. So we're trying to get them to use the evidence that they've just collected from the owl pellet to answer this question about what do owls eat. Another sentence frame would be, I claim owls eat blank and I know this because. So help supporting them to using their evidence and their observations in order to make a claim. Next slide. So that's enough if you want to just have kids explore owl pellets and have a really good time with it. But you can also take this farther. And so once you've got the data about what's in there, you can make some grade level connections to performance expectations. And so here I've listed the 3rd, 4th, and 5th grade performance expectations that I find a connection with. And so can we go to the next slide? Let's see what time it is. 4:46. Okay. And I'm supposed to stop at 4:45. Okay, so I'm going to hurry through this. So there is a lesson plan in the CRS materials. It's a full unit that takes you through the 3rd grade LS 4-4 performance expectation, the merit of a solution to a problem caused when the environment changes and the types of plants and animals that live there may change. So it's basically a scenario where you find out what the owls eat, then you find out what kind of habitat the prey need, and then you think about where they would live and where they wouldn't live. And then we pose a scenario where, well, here's a field, it's going to be bulldozed and the shopping center is going to be built. What's going to happen to the owls based on the information that they've learned by dissecting the owl pellet and learning about the food of the owl? So that's a full lesson plan. There's a whole slide deck and all the attending materials in the CRS resources, and we will give you those links. Next slide. For grade 4, you could connect to structure and function. You could build a mouse skeleton with the bones. There is an actual sheet that is you can see it there on the left side of the slide. It's a laid out mouse, and they can just lay the bones on that and start thinking about the structure of the skeleton and how the different bones function to help the animal move. You could compare mouse skeletons to other animals, and I will give you a manual of images of skeletons of lots of different organisms, humans, cats, frogs, and look and see what are the similarities and differences in the skeleton. And maybe how do those differences affect what they do in terms of how they move. So that's a way to extend the data that you've collected from the owl pellet. And next. And then for grade 5, you could start to use that data to start building a food web for the owl. So if you started with the owl and the vole, you could talk about what are the connections there, and the students could draw that in their notebook to start building a food web. Then you can add some additional information with readings. There's a reading about voles and owls and what kind of habitat they need, what do they eat, get some more information. Okay, well, it turns out that voles eat grass. Okay, now we can add the grass to our food web. Then you can start to think about, well, what physical factors should you include? Because an ecosystem includes both abiotic and biotic factors. And so if we want to talk about the habitat and the food web in an ecosystem, we might want to start adding physical factors. So from there, next slide. You could just, you could give them some icons and have them build it in a Jamboard. You could have them just draw it or use words and just create a food web to think about connections. Can we go back one slide? There's also this book, it's called White Owl, Barn Owl, and it tells a story about a grandfather and a grandchild who observe a barn an owl nesting in their barn. And it tells the story of them watching it, but it also gives a lot of barn owl facts. And it's a really nice book. And there is actually, I found a YouTube video of somebody reading that story if you wanted to use that. But this is a really nice book that would go really well with any owl pellet activity that you would do. Okay, next slide. And then another thing you could do is you could make a vocabulary concept map. So through doing this, they've learned a bunch of words: owl pellet, bone, digestible, undigestible, regurgitate, capture, prey, swallow, habitat, vole, survival. And you could just have them create a concept map that connects all those and shows, group them on a chart and then draw lines between related terms and say, how are these things connected? So just a way to think about the vocabulary that they've learned and the relationships. So these are all just kind of next steps that you could do after you've done an investigation and looked at the owl pellet. Next slide. So I've got a whole, a page full of lots of resources. It's got all the, it's got some videos of barn owls hunting, regurgitating, the bone sorting charts, annual skeletons, all that kind of stuff. And we'll make that available to you. So if you wanted anything, any of those resources to go along with it. There's also food webs, more food web stuff. Mystery Science has a great set of food web activities that are really good. Next slide. And then if you wanted to think about the decomposer food web, if you've done some soil stuff, you could connect that also with your barn owl food web. Next slide.
So I think we're at the end, and I'm gonna stop sharing for a second here and just give folks a chance to sort of thoughts, comments, any experience that you've had with owl pellets before that you wanted to share with the group, or any questions for us.
I know that you've included the owl pellets in every kit, even third grades, right? So we're gonna have, an introduction. Did you say this is mainly a fifth grade kind of activity, or I know anyone could do it, but it's anyone, right? Okay, awesome, good to know.
Do it. It's an investigation. So anytime you're observing and gathering data and making a conclusion, so if you just go through those first steps, you're doing an investigation, you're using claims and evidence. So that's all you need to do. If you want to connect it to some of the third, fourth, or fifth grade performance expectations, those are all listed in the PowerPoint, and with some ideas about how you could make those connections. And I've also included resources, like if you wanted to compare skeletons and think about structure and function, there's resources for diagrams of other kinds of skeletons that you can use.
But see, I just really love all the language support stuff that you offer. And I think it's just like you could do a claims with evidence for any of these activities. Yeah. And you could do that whole word, make like the word box or the new vocabulary and kind of sort it and group it. I just really appreciate all those things, especially coming from a DLI classroom where we're constantly wanting to give a lot of language support, especially in science. And so anyway, thank you.
Oh, that's great. I love to hear that. We love to do that. Science supports language, language supports science.
Yes, yes.
Yeah. So, yeah.
Great. Any other
Uh-huh.
thoughts, comments? If you've had experience and you wanted to share it with your colleagues, we'd love to have you do that. Joe,
I've done it a couple of times with third graders and they absolutely love it. It's a wonderful experience. They're so excited, and then there are the few kids, they're like, ooh, ooh, at the beginning, they're kind of whatever, but within no time at all, they get very excited by it. We're in the classroom. Of course, we're not in the classroom, but when we're in the classroom, that they're jumping out of their seats. They're showing each other what they found. They're running up to me saying, I think I found a skull. I think I found this, so it gets them very, very excited. And afterwards, we have tried to do the bone sorting, which honestly, I'm terrible at. They all kind of look the same to me. But I feel like part of the experience is just actually looking at that chart, trying to see the details, trying to see the differences, and, to the best of your ability, trying to match up what you've found. So even if it's not right in the end, I don't think it really matters. I just think it's making them look really closely at those bones.
Yeah. And I think you hit on it too, because when they're doing the matching, that's a claims and evidence also. You have to say, why do you think that's a this and not a this? So let's compare and weigh the reasoning for, is it more likely this or more likely that, or what features are you using that are telling you? So all that higher level thinking is going on.
and there's, the comparison contrast with the human skeleton too. So you could start talking about the bones in the human body and where they are. And then you may start to be able to tease out some similarities with the skull, for example, or the femur, or the ones that we were looking at yesterday when Betsy and I were taking things apart, looking at the ball joints and the sockets, so we knew that was either a hip bone or a shoulder bone, so that was fun. And then we talked a little bit about too, what you mentioned about, when they're together in the classroom, they naturally do their own gallery walk, right? They get up and they want to see what else somebody else found and they get all excited. It's a little harder in distance learning, but not impossible, to have them be going through their pellets and then sharing the excitement with what they're finding. They won't have the luxury of, this digital microscope that I got loaned from a friend for this one today, or the Elmo, but they can hold it up to the screen, right? If they're not squeamish, they can take that little skull carefully or use the tweezers that we're providing and bring it up to the camera and share their excitement that way. So, but I think that is a really fun part, like you mentioned, Ms. Belanoff, that they share with the exploration and the discovery with each other.
Just to confirm, these owl pellets are from barn owls, the ones that you get, and generally the skulls that you find are from voles, and you can tell because the teeth look like little Christmas trees. They're very, if you look down at the surface of it, it looks like a little Christmas tree. So, yeah.
Thanks, Ms. Weaver, for that comment about the students, even in the distance platform, do get excited. And I know I got super geeky, nerdy excited when I found this guy, because it allowed me to kind of like, oh, I can zoom in and share. But yeah, as you said, Ms. Weaver, just the discovery alone, and Ms. Belanoff, like that excitement, when my wife's teaching TK, when she gets animated with them here at home, it just amplifies their excitement and their discovery. So yeah, I agree. This has become the norm for students this year. So, roll with it. And in some ways it provides a different avenue and way of teaching that provides different kinds of opportunities for, in some ways, some closeness and some that you may not have. We've noticed at home, like she's gotten to know the families really well, obviously this year as a result of distance learning, right? And your students in a different way. But she's also excited because Oakland is going to be going back, everybody on the 19th. So she is excited to culminate the year with some in-class, togetherness, even though it'll be very limited. Last thoughts for the good of the group. Yes, PowerPoint, other lesson plans will be in the email. You don't. Go ahead.
I just want to make a point about the owl pellet dissection PowerPoint and lesson plan. it is designed for a specific thing, but there's lots of images in there of owls and owl pellets and stuff that you could use if you wanted to. So those reasons, you don't have to use it the way it is. You can look at it. Yeah. So I just wanted to make sure you don't steer away from it just because you're not going to use it. There might be something in as it is. There might be something useful for you in there.
Another tip and trick that Ms. Weaver is sharing over the chat, which I have done to, this becomes your dot cam, right? And we've got one of these table, I don't know if you can see it there, but on the table is a little mount and you can stick the cell phone in it, this way. The one issue I had when I tried it, because I had my own Zoom on my computer open plus the Zoom on the cell phone, was I got audio feedback. And there might be a way to get away from that, but I heard my voice was echoing because it was being picked up by the microphone here. Even if I turn mics off, but I think, yeah, this could be a great doc cam right here for sure. Thanks, Ms. Weaver, for that tip. Ms. Weaver says, don't turn your audio on the phone. Yeah, good call. Thank you.
Oh, cool.
Well, we have an exit ticket for you. I'm going to drop it in the chat. It's a quick survey. We would love your feedback from today. What you liked, what you're taking away, any of your, hopefully some of your intentions on the next month and a half of, we have 2 months, about 2 months left of school. So yeah, just any reflections from today would be super helpful for us as we, because we'd like to take this and improve on it, and definitely appreciate your feedback. And thank you. Thanks again for spending the afternoon with us.
Yep, we appreciate all that you do for your kids. And it's always fun to see you.
And I want to say thank you too. Thank you everybody for being here. Thank you, Betsy. Thank you, Eric. Thank you, CRS. Really excited about this opportunity and owl pellets and some seeds. Gonna get our hands a little bit dirty and do some science. So thank you, teachers, for being here and making this happen. Let me know if you have any issues with the materials, but they should all be at your sites. And we're going to use the Zoom report for time cards. So you don't need a sign-in sheet. You're already logged into the Zoom and or a time card or anything. So we're good there as well. So thanks, everybody. It's great to see you.
And Mr. Louie, we'll make sure you have access to that, the last PowerPoint. Not sure why, but it wasn't accessible, but we'll sure.
It is in there. I know it's in there, but I can get the link.
Okay.
Oh, it might be somewhere else. Actually, I'm not. We'll get it to you because I'm not sure if this is the correct one.